You're staring at an n8n upgrade notice. Security wants it this week. Product wants zero disruption. Ops is already carrying incidents from small workflow changes. The risky part is not the upgrade itself. The risky part is upgrading at the wrong time for the wrong workflow. Upgrade too soon, and you break revenue in ops automations in ways that look like random duplicates or missing records. Wait too long, and you accumulate silent failure modes, plus security debt. Both are operationally expensive. Here's the decision rule I use to end the should we upgrade debate per workflow. It's 2 questions. It puts every workflow into a clear upgrade now or upgrade later posture. Then we'll make the upgrade later once move into the safe bucket by hardening what actually falls during restarts. The 2 inputs need to be precise. Criticality is the cost of a bad run. Missed alerts, duplicate changes, duplicate charges, corrupted CRM state, SLA breach. Anything that forces humans to reconcile. State dependency is whether the workflow relies on in-flight state that can be lost, duplicated, or reordered if an execution is interrupted, retried, or a worker restarts. Now compare 2 workflows. Workflow A sends a Slack message when a build fails. If it runs twice, you get 2 messages. Annoying, but recoverable. Workflow B charges a card, writes an invoice, then updates a CRM deal stage. If it runs twice, you have a real incident. If it stops halfway, you have mismatched systems. Same platform, same upgrade, different risks. So here's the policy. If a workflow is high criticality and high state dependency, you upgrade later. Not because you're cautious, because you're missing the controls that make restarts safe. If it's high criticality, low state dependency, you upgrade now, after basic checks. You still validate, but you don't block on hardening work that isn't needed. If it's low criticality and high state dependency, you choose based on effort versus acceptable mess. Sometimes you harden, sometimes you accept the cleanup. If it's low criticality and low state dependency, you upgrade now. The part people misjudge is state dependency because it hides inside it usually works. And stateless safe means you can retry it without harm. Writes and did protect. You have dedupe keys. Replays are safe. Stateful risk looks like this. Multi-step side effects, where step 3 assumes step 1 happened exactly once. Partial writes, where you can create a record, then fail because you store the ID you need to avoid creating it again. Long waits, webhooks, human approvals. Anything that keeps an execution open while the world changes. Pagination without checkpoints, where you're walking pages and you don't persist where you left off. external API calls without dependency, where a retry is not a retry. It's a second transaction. If you want a fast self-check, ask one question and be strict about the answer. If I kill the worker mid-run, do I know exactly what happens on resume? If the answer is not sure, treat it as state dependent. Unknown behavior during interruption is the upgrade risk, because upgrades cause restarts, and restarts surface the not sure paths. Now, the goal is not to avoid upgrades. The goal is to make more workflows quality for upgrade now by reducing state dependency. There are 3 hardening patterns that do that in n8n. They're not abstract. They map directly to what breaks. The first is explicit state persistence. Make progress durable. Decide what state matters for your workflow. Usually, it's a cursor or page token, a last processed ID, external request IDs, already processed markers, correlation keys that let you prove an item was handled. Then, decide when to persist it. Persist before side effects when you need a reservation. Persist after side effects when you need proof. Persist batch boundaries so you can resume without reprocessing the whole batch. And be explicit about resume behavior. On start, read the checkpoint, compute the next work, skip items that are already done using your dedupe marker, continue. That one change turns, I hope it resumes, into it resumes from here. The second pattern is restart testing. Prove it survives interruption. Don't test this with a happy path run. Use a known data set. Start the workflow, then intentionally interrupt it mid-execution. Kill the worker. Stop the container. Whatever matches your deployment reality. Then, rerun. Pass means no duplicates, no missing records, no partial writes. Deterministic reentry in logs, where you can see it skip what's already done and continue. Also, simulate the failures upgrades tend to amplify. Retries, timeouts, rate limits, partial batch completion. If you can't make it fail on purpose, you can't trust it when it fails on its own. The third pattern is worker safe execution. Safe under concurrency and restarts. Start with independency. For every external write, you want a stable independency or dedupe key. Something derived from the business identity of the operation. Not a random UUID generated per attempt. If the target system supports independency keys, use them. If it doesn't, you implement dedupe on your side with a store that survives restarts. Then add guards where needed. If 2 workers can process the same customer, account, or job at the same time, you need a lock or a lease. Something with a timeout. Something that prevents double processing when the queue re-delivers. And be honest about serialization. If parallelism is unsafe, make it single flight with the key. If parallelism is safe, partition by key so concurrency doesn't collide. These three patterns tie back to the decision rule. Checkpoints and dependency reduce state dependency. Restart tests convert unknown risks into known safe behavior. Worker-safe constraints prevent duplicate side effects during upgrade-induced restarts and redeploys. Once you do that, workflows move buckets. The upgrade decision changes without you arguing about it. Now, here's the migration checklist, wording you can paste into a ticket or Notion doc and run the same way every release. Inventory workflows and scope for the upgrade. For each workflow, record criticality as high or low, based on the cost of a bad run. For each workflow, record state dependency as high or low based on interruption and retry behavior. Choose upgrade order. Do low state dependency workflows first. Schedule high criticality and high status dependency workflows only after hardening. For state dependent workflows, add explicit state persistence. Define checkpoint fields. Define when they're written. Define resume logic and dedupe behavior. Add restart testing. Document the interruption method. Document pass and fail criteria. Capture logs that show deterministic reentry. Add worker-safe execution. Define independency keys for each external write. Add locks or leases where concurrency can double process. Serialize by key where needed. Run the upgrade in a controlled window that matches your restart reality. Rolling restart, blue-green, whatever you actually do. Verify post-upgrade with the replay tests on a known dataset. Confirm no duplicates and no misses. Confirm monitoring and alerting still fire. Document outcomes. Note any workflow that required manual cleanup. Note what control would have prevented it. And feed that into the next release. If you want, drop one workflow you're unsure about in the comments using this format. C: high or low. S: high or low. Why? Charges card. Write CRM. Long way. Pagination. I'll reply where it lands and the first hardening step I would do. The reusable rule is simple in practice. Decide upgrade timing per workflow using criticality and state dependency. If it's critical and stateful, harden first, then upgrade. If state dependency is low, upgrade now with basic checks. That's how you stop treating upgrades like a single event and start treating them like a controlled change across different failure modes.